Object-oriented programming is also called OOP. An object is a software component which is very similar to the objects in the real world. It has two components. One is called properties. They are the data related to the object. And the other is called methods. They are the behavior of the object. They're typically the MATLAB functions that can work on the data. The benefit of object-oriented programming is that the data can only be processed by the methods. In this way, that the data can be hidden from the outside of the object. This is a good illustration of a data object. The properties are sitting in the middle, and they are surrounded by methods. In this configuration, you can only access the properties of the object through the methods. In other words, that the actions that can change the properties are well tested so that the properties will be protected from any inadvertent changes from outside world. Before you use a data object, you need to define the class first. Classes are the software blueprints from which the objects are made. It can be the user-defined data type or the MATLAB-defined data type. So this is the blueprint of an object. We call it classes, or we can consider it as a data type. And then we can create the data object based on the class. And we can simply do it using the assignment. And we can have multiple copies of a class. And each class is represented by a variable. There are multiple sections in the MATLAB class definition. The first section is about the properties, and it defines the variables inside an object. The second section is called methods. It defines the functions that related to the behavior of the class, and they are MATLAB functions. And there are two special methods. One is called constructors. It is used to instantiate the class, and it usually provides the initial values of the properties. The constructor has the same name as the class name. In contrast to the constructor, we have destructor, and it is especially used in the so-called handle class that we will mention later. And this method is to delete a class and to clean up any resources used by the data object before it is destroyed. Classes in an object-oriented programming are organized in a class hierarchy. The low-level class, which is called subclass, inherits the properties and methods from the high-level class, which is called superclass, and can add new properties and methods. In other words, the subclass can only need the new code for the new methods added to the class. Sometimes subclass can override the methods already defined in the superclass. In this case, it will use the same method name in the superclass, but provide the new code to process the data. This is a class definition. Here is the keyword class def, and it's followed by the class name. If the class is inherited from a superclass, you need to use a less than sign to indicate the inheritance, and then the superclass name. The superclass must be a MATLAB class or a user-defined class. Inside the class definition, there are multiple sections. The sections for properties includes a list of properties. They are the property names and can be considered as variables within the class. The next section is methods. It is a list of functions, and each function corresponds to a method. There is a special function that uses the same name as a class name. This is called a constructor function, and it is used when the class is instantiated, and it is to initialize the property values. Just keep in mind that you can have multiple sections of properties and methods, and the property or method section can have attributes, and we'll discuss the attributes later. And you can have two properties sections with different attributes. This is the same to the method section. Here is the example of class hierarchy and inheritance. For example, we have a class called vector2D, which represents a vector in two-dimensional space. And it has two properties, x and y, meaning the coordinates of the vector. And we also have three methods, get x, get y, and get magnitude, to retrieve the x coordinate, the y coordinate, and the magnitude of the vector. We can generate a new class, which is vector3D. Vector3D and vector2D has some difference. It has a new third coordinate. And also, it has a new method called the getZ to retrieve the third coordinates. In addition, the method getMagnitude is different from the method in vector2D. Therefore, it will override the methods in the superclass vector2D and provides this new code so that it can calculate the magnitude of the three-dimensional vector. This is a construction function. It has the same name as the class name, and it has an input argument list, and it is used to initialize the properties of the class. The output of the constructor is the object of the class. The definition of a method function is very similar to a regular function. Here is the example. It starts with a keyword function, followed by the output argument list in a bracket, and then the equal sign, then the method name. The only difference here is that the first input must be the data object to which the method belongs, and then followed by the input argument list. If you want to use a function, there are two options. The first option is the regular use of a function. Here you have the output variables to hold the output data, and then you will supply the data object to which the method belongs, and then the input variables. This is the same as the definition. The alternative is that instead of you supply the data object at the first input variable, you will use the form as object.methodFunctionName, and then you only need to supply the rest of input variables.